In the periodic table, there are several trends, and they're called periodic trends. And we're just going to look at two of them. In Chem 1A, you look at a bunch more, but we're just going to kind of get your feet wet with periodic trends, and we're going to look at two. Metallic character is one of them. How metal-like is this element? We've already learned that the nonmetals are on the upper right side of the periodic table. On this table, they're colored in yellow. And the metals are on the left side. In this table, they're purple. And what do we call the ones that are in between, the green ones? The semimetals are metalloids, and they have properties that are kind of between, right? They're like a transition. So the reason I'm giving you metallic character first is because I think it's the easiest to remember the trend of. So when we look at trends, we're thinking about going across a period or going up a group. So down here, this is saying that metallic character decreases as we go across a period, and it decreases as we go up a group. And you can actually figure that out just by looking at the periodic table. Maybe look at group 5A. So group 5A, well, maybe 4A is better. Lead is down here at the bottom. Is lead a metal? Yeah, they used to make pipes out of it, right? It's a metal. So lead's a metal, and up at the top is carbon. Is carbon a metal? No, that's what's in your pencil lead. It's carbon in the form of graphite. That's not a metal. So the trend here, if we're going up, the one at the bottom is a metal, the one at the top is not a metal. It must decrease as we're going up. Does that make sense? And then you could pick a period like maybe period 3, and here's aluminum. Is aluminum a metal? Yeah, that cookie sheet you baked cookies on is made out of aluminum. Sure looks like metal. And then go over here, chlorine gas. Is that a metal? No, that's a nonmetal. So as we go across this way, we go from metals to nonmetals. The metallic character is decreasing as we go across. Okay? So just knowing where the nonmetals and metals are in the periodic table can help you get that one straight. If you can get that one straight, the other one we're going to learn follows the same pattern. So down here it says atomic radius. Atomic radius decreases as we go across, and it decreases as we go up. The same pattern. So you can look at metals versus nonmetals, figure out the trend for metallic character, and it's the same trend for atomic radius. So atomic radius also decreases as you go up a group, and it decreases as you go across a period. What we mean by atomic radius is the distance from the nucleus to the outermost electrons. We can visualize atoms as spheres. So down here is cesium, and the atomic radius would be from the center where the nucleus is to the outer edge. And that's an indication of how large the atom is, right? Large atomic radius, large atom, small atomic radius, small atom. It follows the same trend as metallic character. So here, if we go up a group, we see that cesium is larger, and they're getting smaller and smaller and smaller. If we go across a period, they also get smaller. Lithium, beryllium, boron, carbon, and they just get smaller and smaller, and there's little tiny fluorine. Okay? So we should be able to look just at the periodic table and compare two elements and say which is more metallic and which is larger or smaller. Okay? So let's do that. You may have to look at the wall. Which element should have the larger atomic radius, calcium or beryllium? Yeah, calcium, because calcium is lower. They're both in group 2A, but calcium is below. And as you go up, they get smaller. So calcium should be larger. What color do I have going on here? Let's do purple. Or calcium. Silicon, no, that's not silicon. Sulfur. Sulfur or aluminum? Which one's larger? Aluminum's larger. As we go across from left to right, the atomic radius decreases. If you just think about that, decreasing, it's not going to make a lot of sense. If you're curious about why it does that, I can explain it to you, but I don't want to take time in lecture to do that. How about chlorine or potassium? Potassium's going to be bigger. Potassium's way at the left, and it's also a little bit below chlorine, isn't it? So there's two differences. Chlorine is to the right. Going to the right makes it smaller. Chlorine is also above. It's one period up, and going up makes it smaller. So potassium should be larger. Beryllium or nitrogen, which is bigger? Beryllium. Okay. If we were looking at metallic character and saying which one had the larger or the greater metallic character, the answers would be the same. Okay? Any questions?